And then this is going to equal 180 degrees. So this is your period here. I title this 19.1 C notes. So the domain is always going to be all real numbers. And then for the range, y is between -4 and 4. It's the opposite of the amplitude, and then the amplitude is the upper boundary. And you're going to include both endpoints. So for the graph, let me draw some hash marks here. So it looks like there's 4 on the left. I'm guessing 8 over here. So we're going to be doing 3 full cycles if you see the directions. So I'm going to go up 4 and then down 4 since the amplitude is 4. So for sine, it's going to pass through the origin. Because A is negative, we're going to go down to the min. And then we're going to go to a 0, then the max, and then the 0. That's one cycle. That's a 5-point graph. But we're going to do 3 cycles now. So we're going to keep following this pattern. So it's going to go down to the min. So it's going to go, this would be like your new origin. Then you have min, 0, max, and 0. And then going the other way, if going from right to left, you just came from a min, so the next one's going to be a max. Then you have a 0, a min, and then a 0. So the final graph is going to look like this. I haven't labeled the horizontal axis yet. I'll do that in a second. So to label the horizontal axis, I'm going to do the period divided by 4. So that's going to give me 45 degrees. So if you want to do every other one, you could. So this would be 0, give yourself more room. So 45, then 90, then 135, then 180. So that's one period, 180 degrees. Then if you're doing every other one, you're adding 90. So then it'll be 270 and then 360 at the end. I think I skipped one here. But it'll be 270. And let me change 180 to be right here. And then it'll go 270 and then 360. Go in the other direction, it would be -90 degrees and -180. So make sure you label the horizontal axis. And that should do it for that one. So any questions on this first example here?
Nope. Got it.
Oh, okay. That's okay. So coming over here, let's see if we can do. Okay, so clearing this out. So for the next one, we have g of x, we're going to the right. So g of x equals negative cosine of pi theta, and it says in radians. So I'm going to draw the graph again. So I'm going to go 8 hash marks to the right. You don't have to do the hash marks because they're already on your notes. 4, 5, 6, 7, 8, and then 4 to the left. So I'm going to find the amplitude, which is the absolute value of -1, equals 1. The period, because it says it's in radians, it's going to be 2 pi over b. So B is going to be pi. That's the coefficient of theta here. So this is just going to equal 2. So when I'm drawing the graph, I'm just going to go up 1 and down 1. Since my amplitude is 1. To figure out your scale, you're going to take your period and divide by 4. So that's going to be 1/2. So that means if you're doing every other one, if you're going by 1/2, it'll go 1, then skip 1, 2, skip 1, 3, skip 1, 4. And if you're going to do every other one, if you're going by 1/2, it's -1, -2. So the domain is always, theta is all real numbers for sine and cosine graphs. For the range, the opposite of the amplitude is -1, and then the amplitude is 1. So that's going to be my range. So for a cosine graph, its y-intercept is either a max or a min. So because it's negative cosine, it's going to start, A is -1. We're going to start at the min. And then hopefully, knowing that one point, you can easily get the rest of them. From the min, it has to go to a 0, then a max, then a 0, then a min, then a 0, then a max, then a 0, then a min, then a 0. Going to the left, from a min, it goes to a 0, then a max, then a 0, then a min. So this is what my graph is going to look like here. So hopefully this isn't too bad using the whiteboard, and you guys have the notes in front of you. So now I already labeled my axis. We should be done with this one. So any questions on the second example here?
Wait a second. Hold on, Mr. Morrison. It was like slow for me. Hold on a second.
Okay. We're okay?
Yeah.
Okay. So going on to the graph, we're working backwards. So now the final example on this page. So we're still on 19.1c. Okay, so looking at the graph, you can see the amplitude is going to be 1.5 because the highest point has a y coordinate of 1.5. So the period, you have to look at how far it travels before it repeats another cycle. So it looks like it travels a distance of, I think it's 4. So if you go from x equals 0 to x equals 4, that would be 1 5-point graph. So the period is going to be 4. The domain, I'm working on the right side, is all real numbers. The range is going to be y is between the opposite. Okay, I'm going to mute everyone here. Let's see. So just make sure to, as always, unmute yourself if you need to say something or ask a question. Okay, so right here it's between -1.5 and 1.5. So this is all on the right side of the example. So this is going to be a cosine graph because its y-intercept is a max. So I'm going to write the formula for cosine. So y equals a cosine of b theta. So a, because the y-intercept is a max, it's going to be positive. So a is the same as the amplitude, positive 1.5. If you want to find b, you can see how the axis is labeled. Be careful here, because sometimes students think if they don't see pi, it must be in degrees. How you know it's not in degrees is because it doesn't have the degree symbol. So this one's actually in radians. So the period is going to be 2 pi over b, not 360 over b. So I know the period equals this, and it also equals 4. So I can set those two things equal to each other. So 4 equals 2 pi over b. I can switch the 4 and the b. So when I simplify this, b is going to be pi over 2. So now I have b, I have A, that's everything I need to plug in for my answer. So my final answer is going to be y equals 1.5 cosine of pi over 2 times theta. Another way to write pi over 2 times theta is pi theta over 2. And you can check this on your graphing calculator. Just make sure you are in radian mode if you're using the same window of the graph from like -4 to 10 on the x-axis and from -4 to 4 on the y-axis. So any questions on this one before you turn your page in your notes? Everyone's doing okay? Say yes if you're doing okay.
Yes.
Thank you. Nice to hear some feedback.
Yeah,
Something
we're good.
Sounds good. All right, so we're going now to the last lesson of the year, 19.2. So I'm going to clear this out. So make sure you read everything up there. I can't really highlight anything, so just look at everything. The big difference for 19.2, if you look at the very top of the page, hopefully everyone sees plus K. So we're doing a vertical translation. We're shifting our graph either up or down. So everything else is the same. How to find A and B are all the same. We're just going to be adding K. And there's a couple ways you could do this. You could do two separate graphs where you just graph it without K, and then at the very end translate it either up K or down K if it's positive or negative. But I'm going to show you what I think is an easier way to do this is using what's called a midline. So, and you treat the midline as your new x-axis. So let's look at, I'm at the bottom left now, where it says y equals 3 sine theta plus 1. This is in radians. So we're just going to do one cycle, so a 5-point graph here. So this would be your graph. We're going to go over 1, 2, 3, 4, 5. And again, you don't have to draw this since it's already on your notes. I'm going to call this the y-axis and this the theta axis. Okay, so for this one, because our k is 1 here, what I'm going to do is I'm actually going to go up 4. Then I'll go down 2. Because our k is 1, that means I'm going to shift the horizontal axis up 1. I'm going to make it a dotted line. So this is called the midline. So the midline would be the line y equals 1. And from here, you just treat this as your new horizontal axis, and everything else is the same. So for sine, the origin would be like right here. Because remember, sine graphs always pass through the origin, but if you're shifting the horizontal axis up, it's like shifting the origin up 1. So we're basing this green dotted line, we're treating that like our new x-axis. And then everything else is the same. You can ignore the plus 1 now. Okay, so let's go do what we've always done. So the amplitude is the absolute value of 3, which is 3. The period, this one says it's in radians. It tells you that in the problem. So it's going to be 2 pi over b. So our b, there's an invisible 1 in front of the theta. So the period is just 2 pi. If you want to find the scale, you take your period and divide by 4, which is going to be pi over 2. So that means this would be pi over 2, and you keep adding pi over 2. So pi, 3 pi over 2, and then 2 pi. And when you're using the amplitude, it's going to go up 3. If you're thinking of the green line as the new x-axis, it goes up 3 from that, and it goes down 3 from that. So it's going to go up to 4 and down to -2 on the y-axis. So drawing the graph for sine, because a is positive, from this is like a 0 here. Even though it's technically not a 0, it's not an x-intercept, but you're treating it like an x-intercept. So it's going to go from a 0 to a max to a 0 to a min to, I didn't need so many hash marks here. So this is one 5-point graph. Let's see, am I missing anything? I think we're good. So any questions on this one using the midline? So the midline is y equals k. K is the constant. All right, so we're gonna do another one of these. I don't know if I want to do these for, I don't know if I want to do 6 examples here. I'll do the next one on this page, and I'll maybe pick and choose on the next page. All right, so I have 6 examples of graphs. That was the first one, so maybe I'll do like 4 of them. So that was number 1. Okay, so still on the first page of 19.2, it says y equals cosine of pi over 4. Backtrack. Cosine of theta over 4. Maybe I had that right, I don't know. Theta over 4 minus 3. And then for the graph, we're gonna do another 5-point graph here. So I'm just gonna go 1, 2, 3, 4. This is my y-axis, this is my theta axis. So the amplitude is the absolute value of 1, which just equals 1. For the period, it's gonna be, this one, it tells us in the problem that it's in degrees. So it's gonna be 360 over b. And our b is gonna be 1/4 here. So there's a 1/4. So dividing by 1/4 is the same as timesing by 4. So that's gonna be 1,440 degrees. So to find this scale, you take 1440 and you divide by 4, that'll give you 360. So for my scale, it's gonna be 360, 720, and then 1080. If you wanna do every other one, that's fine. And then 1440. So this one, I'm labeling my y-axis. We're going down 3. So I'm actually gonna go down 4 because the amplitude is 1. I'm gonna draw my midline. So my midline is gonna be y equals -3. And the midline, think of this like your new x-axis, your new theta axis. So that's called your midline. It's the horizontal line that is kind of like, it's in between the highest point and the lowest point. Because the amplitude is 1, I'm gonna go up 1 and down 1 from the midline. So it's, the entire graph is gonna be between those 2 red highlighted lines. Because it's cosine and a is positive, I'm gonna start at the max. So right here is my max. And this would be like my 0, and then a min. And this would be like my 0, and then a max. So this is what your final graph is gonna look like here. Again, you please remember you can check these on your graphing calculator. Just make sure you're in the correct mode. Like this one would be in degree mode. For your window, your x min would be 0, your x max would be 1440. For your y min, I don't know, you could use like -5, and your y max could be like 5 if you want to make the graph look like this one. Hopefully Vanessa gets her calculator back. All right, so any questions on this one here? Okay, so the next page, I don't think I'm gonna do all 4 graphs. I do wanna do the last 2. Maybe I'll pick a couple of them. So let's see. Okay, I'll do All right, I'll tell you which ones I'm doing. So pay attention to which ones I'm doing here. Okay, so I'm not doing the first one on the next page. I'm doing the one on the top right. So it's y equals 2 minus 4 sine of theta over 2. So this one you have to draw the graph anyway. So we're kind of on a level playing field now. Okay, so draw the graph. Okay, so this one has a midline of y equals 2. The constant is at the beginning. Don't get confused. It's out of order. So the y equals 2 is going to be the midline. And then if the amplitude is 4, I'll write that off to the side. So the amplitude is the absolute value of -4, which is 4. That means I'm going to go up 4 from the midline. So 1, 2, 3, 4. Then I'm going to go down 4 from the midline. 1, 2, 3, 4. So my graph is going to be between 4 above the midline and 4 below the midline. So I like putting little markers there so I don't go too high or too low on my graph. Just like in life, you don't want to get too high or too low. Always analogies for math classes to model real life situations. Okay, so here it's a sine graph where our a is -4.
Wait, Mr. Morrison.
Yes.
So okay, the two in the front, it's the same thing as if it was in the back.
Yes. So like if you said like 2 plus 4x, that's the same as 4x plus 2. So don't, if the constant can come at the beginning or the end. So in this case, a little tricky because the constant is at the beginning. Usually k is at the end, but not for this one.
Okay.
Okay. So yeah, k equals 2 here. So the midline would be y equals 2. Let me go back before I keep going. Let me find the period. So the period, it tells me problem. This one's in degrees. So it's 360 over b. So my b is 1/2 here. That's the coefficient of theta. And dividing by 1/2, you know, is the same as timesing by 2. So the period is 720. Make sure you put the degree symbol. Okay, and then for the scale, I'm going to take my period and divide by 4. That's going to give me 180. So I'm going to do 1, 2, 3, 4. So it's just going to make the scale by 180. So you just keep adding 180 to itself, to the previous value. So 360, 540, and 720. So for a sine graph, normally it passes through the origin, but this one, the whole graph is shifted up 2 units. It has a vertical translation of +2. So this would be like my new origin right here, where the midline meets the y-axis. And then because a is -4, it has to go down to the minimum. So from the starting point, we're going to go down to the minimum. And then this will become like a 0, just shifted up 2. And then we have a max, and then a 0. And this is what the final graph is going to look like here. So this is the example on the top right. Any questions on this one?
Nope, I'm good. Thank you.
Good, okay. I'm gonna clear this out if there's no
Wait,
questions.
wait, don't clear it yet.
Yep, okay. So the next one, I'm not gonna clear it just yet. The next one we're gonna do, we're gonna skip the negative cosine theta over 3. That'll be the last one we skip. So I'm gonna focus on the next example, which says y equals sine of pi over 2 theta plus 1. Are you okay, Sierra? Okay. All right, so going to the next one. It's y equals sine of pi over 2 theta plus 1. We just have 2 more to go after this one, and then we're done with notes for the year. So we'll do the last two graphs at the bottom after this one. We're working backwards. All right, so this one, it says in the directions to do 2 periods. That means we're gonna do 2 cycles. So instead of going over 4, I'm gonna go over 8. So 1, 2, 3, 4 is 1 cycle. 5, 6, 7, 8 is another cycle. So this one has a midline of y equals 1, because that's your k. Okay, so for this one, the amplitude is the absolute value of the number in front of sine. So the absolute value of 1, which is 1. And then the period is 2 pi over, actually, wait, let's see. Yeah, it says in radians. So 2 pi over b. So the b here would be pi over 2. So dividing by pi over 2 is the same as timesing by the reciprocal, 2 over pi. The pi's are going to cross cancel. So you're just left with 2 times 2, which equals 4. And for labeling the axis, you take 4 and divide by 4, which is 1. If your scale is 1, you don't actually have to label it. Anytime you don't label an axis, I'm assuming you're going by ones. So if the scale is by ones, don't even bother labeling it if you don't have to. In the y-axis, I always just go by ones for these graphs. So if my amplitude is 1, I'm going to go 1 above the midline. So it's going to be between here and here is the entire graph. Okay, so drawing this graph. For a sine graph, it normally passes through the origin. But in this case, we're moving the graph up 1. So the first point is going to be where the midline intersects the y-axis. And because a is positive 1, it's going to go up to the max, and then the 0, and then the min, and the 0. This is going to be 1 cycle. Then I'm just going to keep following the same pattern. So 0, then max, 0, min, 0. In classes, you call this a wavelength. That's what sine and cosine graphs do. Every cycle is 1 time around the circle, if you're connecting it back to the unit circle. Because then remember, for a sine graph, it's the y-coordinate of different points on the circle. So we're just graphing all the y-coordinates going around the circle. Creates a wavelength. Okay, so this looks like this here, this here. So that is my graph. Am I missing anything? I don't think so. Maybe I'll just call this y and this theta. I don't know if I did this on the last one. So my y-axis and my theta axis. And the last example for graphing doesn't even include a k. So it would be more like ones we did from previous lessons. K would be 0. You don't have to worry about a midline when k equals 0. All right, so any questions before we go to the last two at the bottom of the page?
Yeah, so Mr. Morrison, the other 2 problems that we have, do we do those on our own?
If you want, yeah, I could. They're pretty much the same as the other ones we're doing. Those are just for extra practice. I think by doing the ones we did, you should be good for the work. But if you want to try those on your own, that would be good practice. You could check it on your graphing calculator too. So yeah, that would be a good idea to just try doing those.
Okay.
I just don't know if you guys need 6 graphs. I think by doing 4, I think that should be enough for you.
Oh, yeah, okay. Thank you.
And you probably don't want to stay here till 12. Some of you have to get lunch.
Yeah.
The good thing is next week we'll even be less stressed for time because it'll just be going over homework and then working on the final. Okay, so the last 2 graphs here. Everyone's okay? I can clear this out. Okay. It's nice if I have the graphs, but we can make do. I think we're making this work okay. I wish I could have projected, but somehow it's not sharing my Google Drive today. And then even my plan B was having all these issues. So no, it's a rough day when plan A and plan B both don't work, but we're managing here. So thank you for being flexible, everyone. Okay, so this last graph, I'm gonna have you tell me. I'm gonna have someone with their mic turned on. The one on the bottom left, is that a sine graph or a cosine graph?
Sine.
Sine. So I'm not going to draw a pretty graph here, but I'll kind of give you just a general idea of what it looks like. So it looks kind of like this here. Just do a rough sketch and you can see the graph on your paper. Okay, so I'm going to draw a midline. You can see the midline is somewhere between the highest point and the lowest point. So this point and this point would represent one of the highest points and one of the lowest points. This one has a y-coordinate of 1. This one has a y-coordinate of -5. So if you want to find the midline, it's going to be the average of those y-coordinates. So for the midline here, you're going to average 1 and -5. So y equals, when you average them, you add them and divide by 2. So y is going to be -2 here is your midline. So this is the line y equals -2. And how you know it's sine, you look at the y-intercept. That y-intercept is the origin translated down 2 units. So anytime it's like the origin, you know it's a sine graph, because it's the origin translated down 2, and sine, if assuming there's no translations, always passes through the origin. Its y-intercept is 0. So that's how you know it's a sine graph. So for any sine graph, up until today, you would have left it like this: a times sine of b theta. But you can see that anytime you have a midline, that means you have a k value. So you need to know what k is, which we already know. K is just -2. So then I need to know a and b. So if you want to find a, it's the distance from the midline to the highest point, or the distance from the midline to the lowest point. So if you want to go from -2 to 1, how far do you travel on the number line from -2 to 1?
3.
3, thank you. And it's going to be +3 because it's moving up from the translated origin. So if it was moving down from the origin, then it would be -3. So a is going to be 3 here. And you could also say it's going to be 3 from -2 to -5 is also 3. So a is always the distance from your midline to your highest point, or the distance from your midline to your lowest point. But remember, it could be negative, depending on what the graph does from the y-axis. So to find the period here, I'm going to do one 5-point graph. So 1, 2, 3, 4, 5. So it's this distance right here. So if you look on your graph, that looks like it travels a horizontal distance of 2 pi. So the period is going to be 2 pi. Everyone can see that on their graph, that if you do a horizontal distance of 2 pi, it completes 1 cycle before it repeats the pattern again. So you just did a 5-point graph: 0, max, 0, min, 0. That travels a horizontal distance of 2 pi. So the period is 2 pi, but the period is also going to be 2 pi over b, because it's labeled in radians. You don't see any degree signs on the horizontal axis. So to find b, I'm going to set these two things equal to each other. So 2 pi equals 2 pi over b. You can switch the b and the 2 pi on the left. So 2 pi divided by 2 pi is just 1. So now I have everything I need. I have b, I have k, and I have a. So my final answer is y equals 3 is my A, sine of B equals 1. So 1 times theta is just theta. And then our K is -2. And again, you can check this on your graphing calculator. Make sure you are in radian mode. For when you click on window on your graphing calculator, you can do your x min is -2 pi, your x max is 4 pi, your x min would be -5, and your y min would be -5, your y max would be 2, just like on your notes. And it should look just like this when you say y1 equals 3x or 3 sine x minus 2. So any questions on using your graphing calculator to check? Are any questions on this example before we go to the last note example of the year? Okay, I'm clearing this out. We are now on the last new example of the school year for notes. It's kind of bittersweet. Okay, so right here, I'm gonna just do a rough sketch of the graph again. I'm not gonna make it perfect, but just so you kind of get an idea of what it looks like. So it goes like this. I'll try to make it kind of nice, but it's definitely not gonna be perfect. Okay, so it's gonna have a midline somewhere halfway between the maximum and the minimum point. So if you locate one of the maximums, it doesn't matter which maximum you use. Someone tell me what's the y coordinate of the maximum point?
2. Wait.
That's the minimum.
Oh, wait. Oh.
The minimum has a coordinate 2. What's the y coordinate of the maximum point?
Sorry, 6. My bad.
It's okay. So y equals 6. Problem? So for the midline, it's going to be y equals, you just average the y coordinates of the highest and lowest points. Sometimes you could just do this by looking at it. You don't have to show any work here. So, but when you average these, you have the 6 and the 2 and divide by 2. So that'll simplify to y equals 4. So this would be the line y equals 4. So it's important to know the equation for the midline. That also tells you what k equals. So k is going to equal 4. It's the same number that goes with the midline. So can somebody speak up with their mic turned on? Is this a sine graph or a cosine graph?
Cosine?
Cosine. Look at the y-intercept. Anytime the y-intercept is a minimum, a lowest point, or a highest point, it's a cosine graph. And because it has a midline, I can't forget about the k. So when I'm writing my equation, it's going to be a times cosine of b theta, and then we're including plus k for this problem because it has a midline. We're translating the mother function vertically. The mother function would be y equals cosine x. Okay, so A is the distance. How far do you travel to get from 4 to 6? Somebody tell me, from 4 to 6.
2.
2. How far do you travel to get from 4 to 2? How far do you travel to get from 4 to 2?
2.
2. So either way, from the midline to the max, or the distance from the midline to the min, you're focusing on the y values. You're traveling on a vertical path. So it's perpendicular to the midline, the path that you're traveling. This one is interesting though, because we have a minimum as the y-intercept. So that means A is going to be -2 here. So you always have to think, even though the amplitude is always positive, A can be positive or negative. So for cosine, you're asking the question, is the y-intercept a max or a min? Whenever it's a min, you make it negative. For sine, you're looking at what does it do after it passes through the origin or the translated origin. Is it going up to the max or is it going down to the min? If it's going up to the max, A is positive for sine. If it's going down to the min, A would be negative for a sine graph. So the last one, it was going up to the max from the origin, so the translated origin. So that's why it was a positive A. But now A is negative. Okay, so here, let's see. So it goes 0, or min, 0, max, 0, 0, min. So what's the horizontal distance we are traveling here? Somebody tell me. That's the period. We're finishing
6
strong.
pi.
Somebody tell me what's the horizontal distance for one cycle here.
6 pi.
6 pi is correct. So this right here would be 6 pi before it does another 5-point graph. So that's one cycle, has a horizontal distance of 6 pi. So the period, this one, you can tell by looking at the horizontal axis, it's labeled without the degree symbol. So that means it's in radians. So it's going to be 2 pi over b. So I'm going to set these two things equal to each other to solve for b. So 6 pi equals 2 pi over b. You can switch the b and the 6 pi to save you an algebra step. So the pi's cancel out. 2 over 6 reduces to 1/3. Now I have everything I need. That says 1/3 at the bottom if you can't read that. 1/3. So now I have K, I have A, and I have B. That's what I need to plug into this formula and just do that. And we are done with notes for the year. Still can't believe it. So Y equals A, which is -2. Cosine of B, 1/3 times theta. The better way to write that is theta over 3. That's the same as 1/3 theta. And then plus K. Our K is +4 here. So again, it's important that you can check these on your graphing calculator. So if you want to do that now, change your window. Your X min, maybe I'll write it here. So X min on your window would be -2 pi. Your X max would be 12 pi, just so it matches the graph in your notes. Your Y min would be 0. Your Y max would be, looks like 7. And then when you're doing it on your graphing calculator, you hit Y equals, and then it'll be Y1 equals, just use X instead of theta. So it'll be Y1 equals -2 cosine X over 3 plus 4. Make sure you're in radian mode. If you're not in radian mode, it's not gonna look anything like this graph. So your mode needs to be in radians. So make a note here, radian mode. So this is what you would need to do on your calculator, and just you would change theta to an X. But when you're writing the equation, you should use theta. But on your calculator, you would use X. So any questions on using your calculator or this last example? Anyone need me to leave this up longer? Okay, I'm gonna stop share, just quickly wrap it up by talking a little more about the final, and then we'll call it a day. Just give me a couple minutes. Okay. So, yeah, we will be meeting again next week on Zoom, same time, 10 a.m. Thursday. We'll be going over homework, and then I'll give you time to work together. I'll probably put you in groups and allow you to work together on the final. But if you want to work on your own in groups, that's fine too. But again, the big thing I want to emphasize is make sure that you are doing your own work, because I will be checking the work closely. That's a big part of your final grade, is turning in your own work. But you can work together on getting the answers, on making the videos, things like that. But just make sure for like the videos, there's two parts of the final. Actually, it's going to go in the grade book as 3 parts, but there's really 2 parts. So the first part is the video. Hopefully you had a chance to look at that. Oh, I had my video on the whole time. Weird. So everyone got that yesterday. Read the rubric closely so you know exactly what's expected. So you have time to do it, but don't wait till the last minute, because that's, if you're starting right away. There's no reason you shouldn't get a very, very good score, hopefully 100% on it. That's part one of your final. And the final is worth 20%, but the grade cannot drop below your baseline grade. And again, I'm trying to set it up so for the extra credit you've earned, I don't want the final to take your grade down. I'm trying to make it so that as long as you're putting in the time to do it, you're working together, asking questions, the final should be used to help your score. But it is possible that your grade can go down. It just won't fall below your baseline grade. So I'll be checking, I'll be comparing it to your baseline grade to make sure that does not happen. And if I need to make adjustments, I will. So that's part one of the final, making the video. So everyone's doing their own video and you're gonna submit that on Google Classroom. And then the second part of the final is the multiple choice, which I'll try to finish it this week and get it to you as soon as I can. That won't be due until May 21st. And again, you can, same thing, you can use your notes, work together, just make sure to submit your own work. That's very, very important. So any questions from you guys? Okay, so you have the last two assignments. You can start working on your final anytime. And if you have questions, stick around. If not, stay safe, stay healthy. Hope you have a great week, and I will see you all on Zoom next Thursday at 10 a.m. So take care, everyone.
Bye, Mr.
Have a good weekend, Mr. Morrison.
Bye. You too. Everyone wash your
Have a
hands.
great day, Mr. Morrison. Stay
You
safe.
too, Ethan. Bye, Vanessa.
Have a great day, Mr. Morrison.
You too.
Mr. Morrison, I had a quick question about the final.
Yeah.
So, do you want us to make the video with like a phone or just with?
A phone, fine. However you make the video is up to you. Just make sure you can submit it on Google Classroom, but it should allow different like file types as far as I know. Hopefully there won't be any issues with that.
Okay, that sounds
So
fine.
you could just work it out on hand and then just have a recording as you talk about your steps and what you did.
Okay.
Make sure like for the first one you give 2 exclamations because do follow the directions carefully.
Yeah. Okay. Thank you.
Okay. No, thank you.
Bye. Have a good
Hey,
weekend.
you too.